Hello learners, welcome to Introduction to Machine Learning in Data Science 2 module. We are going to use Scikit-learn module for our machine learning class. For this course, we are going to provide an insight by training, evaluating, selecting the best classification model for predicting unknown categorical label, and we also do for regression to predict values. We will learn how to apply the following classifiers and regressors to a dataset: logistic regression, k-nearest neighbor, support vector machine, decision trees, random forest, and gradient boost. Now, our Scikit-learn is a library in Python that provides many supervised learning and supervised algorithms for machine learning. It is built upon some packages that you are already familiar with in our earlier lessons, like NumPy, like Pandas, and Matplotlib. So with Scikit-learn module, you can train different machine learning modules such as regression and classification and check their performances using any of the metrics that we are discussed in Unit 2. For Scikit-learn module, some of the functionalities that it provides include preprocessing, regression, classification, clustering, and model selection. Our last session for this class will be that we will open a machine learning and classification regression Jupyter notebook for our lesson. Please come along with me while I show you how to run Python code in Python Jupyter notebook. Now, this is our folder for script and data science CS31. We will start by learning how to use Python for classification using machine learning. So if you click on it, it will take you to the machine learning classification Jupyter notebook. So for this machine learning Jupyter notebook, we are going to learn how to use the following models like logistic regression, k-nearest neighbor, support vector machine, decision tree classifier, random forest, and gradient boost. But before we do that, we will have to import our algorithm or our model into our work by using from sklearn linear model, you import the logistic regression. Likewise, you do that for the k-nearest neighbor too by importing the classifier, and then you also do that for support vector machine also by importing the classifier. Now, the data set that we will use as our training is health provider data set in Ethiopia. And the problem we want to solve, or the task before us, is that you as an analyst in the marketing department of a company that provides various medical insurance in Ethiopia. So your manager is unhappy with the low sales volume of a specific kind of insurance. So as a data engineer, you are provided with a sample data set for those that visit the company website for medical insurance. So the task before us now is that we want to be able to classify those that purchase insurance, medical insurance, and those that did not purchase medical insurance. And the data set contains the following columns. You have the user ID, you have the gender, you have the age, you have the salary, and you have your target purchase, indicating whether the client purchase, which we are going to represent as 1, or not purchase the medical insurance, which we will represent as 0. So our plan now is that we want to build a classifier that will predict whether a person that visits the insurance company will buy the insurance or not. So we will use this for training the logistic regression, random forest, naive Bayes, extreme gradient boosting, and support vector machine. As we know earlier in our earlier classes, that before in our earlier classes that we have to import the libraries that we have to use for our machine learning model. Remember that we had already known about NumPy, so we will import NumPy as NP, we represent it as NP. We also import pandas and we represent it as PD. Then we import matplotlib.pyplot as PLT and cbon as SNS. This matplotlib and cbon, we'll use that for visualization. So as my cursor is on the first cell, I'm going to run it, and if you have this empty, that shows that there is no output. It's a clean cell. You initiate it by clicking on the run icon. So when you click on the run icon, when you see this star, shows that it is still running, and when it eventually gives a value, then you see that it has successfully run that cell without an error. So the next thing we'll do is that we read in our data set, and we use that you turn the data set into a panda frame using the read statement, and our data is in the CSV format, and we will name our data set insurance. Now, the second line of code is instructing the code to bring out a sample of the data set for us to be sure of for us to be sure whether the data set is read, is what we actually need. So, and this is very, very essential. So after running the code, we see that it brought in a data set showing us with a user ID, we have gender, we have age, estimated salary, and purchase. So this is exactly how our data set looks like, and it is a good thing that it imports the right data set. So we move on to the next column, insurance.shape. What this shape represents is that it's going to show us the number of rows or the number of instances contained in the data set and the number of variables or columns contained in the data set. So if you run it, we see that we have 5 variables and 400 instances of those that wishes to buy insurance or does not want to buy the insurance, medical insurance. So as we all know, this user ID is generated at random, so it is not going to contribute anything to your classification. So we can as well do away with the user ID by removing it. So that is what the next row of code will do with the help of this keyword drop. So with this keyword now, it's going to drop the user ID column because we don't need it for classification. If you click run, so it has dropped it, but we want to be sure whether it has removed the user ID or not. That is why we are calling for the data set again. That's why we have it .head .number that we want to see, and it happens that it has been removed. The user ID has been removed. So our data set now, instead of the original 5 variables, we now have 4 variables. So now the next thing that we want to do is that we want to transform our purchase, which is a categorical variable. We want to transform the variable to a numeric variable. So we can call this purchase, we can either call it class, we can call it target, or we can call it label. They all mean the same thing. So now, how do we convert our text to number? Specifically, we want not purchased to be 0 and we want purchased to be 1. So this code will do that for us by applying this lambda here and executing this if code. So if your label is purchased, then you write 1, or else if it is not purchased, you write 0. So it's going to do that for us. And after executing the code, we still need to confirm whether it has changed it to what we expected or not. That's why we click the run again, we run the code, and surprisingly, it has done that. So for purchase, we have not purchased and purchase. So now we have 3 features that include gender, age, and estimated, while purchase is the label, it is the target of the data. So since we have just 2 classes or categorical variable purchase and not purchase. So we regard a problem like this as binary classification problem. Of course, we could have more than one classes. We call that a multiple class classification problem. Now, the next thing that we will do is what we call exploratory data analysis. This is very essential as it allows you to understand your data better before you move on to model building. So the next thing that we will do is that we want to see the insurance data. We want to see how many people purchase the insurance and how many people did not purchase insurance in a visualized mode. So this is what we have, and this is easier to be read. This is a bar chart. Now we see that not purchase is 0. So we have more customers that did not purchase the medical insurance plan than those that purchase. So now we want to see the gender of people that purchase and did not purchase the insurance. So we see that here more female purchase the insurance than male. With this plot now, it shows us that we have more female than the male in the data set. Now, the next thing is we want to see the number of male and female that purchased and did not purchase the medical insurance. So we see that here for the gender, we have more male that did not purchase the medical plan than the female that purchased the medical plan. So the next we'll see is purchase versus age. We want to see the number of people in a certain age category that purchase the medical insurance plan than another. From here, we'll see that we have older people purchasing the medical insurance plan than younger people. So that is why the box plot is higher for purchase than not purchase. Now we also want to see the category of people that purchases this medical insurance with the size of their salary. If we run it, we'll see that the people that earns higher salary, they purchase more plan than people with lower salary. So this shows that the company should concentrate their effort more on people that earn higher salary than people that earn a lower salary. Now we move on to model building. As our tradition, before you could start building your model, you have to import the metrics that you will use to measure your model, and you have to also import the test train split ratio package that will split your data into train and test. So now we have successfully import our metrics and our model selection sites. Now, the next thing that we move on to is after splitting the data, we still want to remove or drop the target column, which is purchased. We want to split it into two and name X all the features or all the label in your dataset and Y as only your label. So when you click it now, you have successfully split the data into features and target. So let us try to see what kind of data we expect to see in our X. You'll see that we only have the variables like gender, like age, and the estimated for our X. So what kind of variables do we have for our Y? We discovered that we only have the target, which is purchased for Y. As we have discussed earlier in our part 3, the lessons we learned there, we create a one-hot encoding for all categorical features in the data because some algorithms cannot work with categorical data like if you write a male, you write a female. So because of that, we need to convert the input variable or the output variable into a numeric value. So in this case, we are going to use one-hot encoding by using a get dummy code. So with the get dummy code, since gender is what we want to transform, you run the code for gender and it has transformed your gender value from male, female to zeros and one. So this get dummy variable keyword is very powerful to actually locate the categorical features and create a one encoding for all of them. And this is an example. So now for each of the rows, we have the gender female and the gender male as they are split into their respective columns. So now we now represent our new data set now, because this is our new data set, as X, and we will still try to read it and we see that it's the same as what we have above. Now the next thing to do is to split our data set into two, because as we have discussed in A, we will split our data set into features named X and label named Y into training and test data by using this train test split function from the Scikit-learn. So for this purpose now, we are going to split our data set into 80%, while the test data will be 20% and our random state will be 1, 2, 3, 4. So now if we run that, our data has been successfully split into two. So we have a trained data set that is 80% of our data size, and we also have 20% reserved for tests. So now we move on to model training. So for our model training now, we are going to start with logistic regression. So before you start with logistic regression, you first of all have to import the classifier logistic regression by using this code. So after importing the logistic regression model, so the next thing to do is to instantiate a class of logistic regression, and you fit your data to the logistic regression model. So this is our trained data, which is 80% of the original data. So if you run it, we see that a logistic regression model has been successfully instantiated. So the next thing to do is to predict with your tested, which is 20% of what we have, and this is what we have. From this result now, we can see that everything is not purchased, which is 0, 0, 0, showing the result of our modeling. And now we want to learn our test data on the logistic regression model. As we have said earlier, after training and testing your model, we need to measure the performance of your model. So one of the metrics that we use is a confusion matrix, which we have talked about earlier. So this is the code to run the confusion matrix. Now we want to run confusion matrix on the logistic regression model, which we have used to train our data sets. Now, from what we can see here, we see that from we have 54 that were correctly classified as not purchased, and we have 26 that were wrongly classified as not purchased. So what this model has successfully done was that it has classified all instances, all customers, all clients as they have not purchased the insurance, but that is not true. We have some that purchased the insurance, we have some that did not purchase the insurance. So because of that, let us try and see the accuracy at which this model have learned the data set and built a model for it, a classification model for it. So we have 0.657675, which is equivalent to 67.5%. Then we see that we cannot trust this accuracy since the data set is kind of imbalanced. That is, the number of purchase and not purchase, they are not equal. So we could also use another metric, which is F1 score, to test for the accuracy of the model. And with the F1 score, the value is 0. So this shows that this model is not efficient to predict whether or not a customer will buy the insurance. So because of the low return value for F1 score, this model, we regard it as a naive model which cannot build an efficient classification model. So we now move ahead and try another machine learning model called Naive Bayes. Now, with the Naive Bayes now, as our tradition, the first thing we do is that we import the model Naive Bayes as Gaussian NB. Then we instantiate a class for it, building Gaussian NB. Then we also try to fit our data into the Naive Bayes model. Then we click run. So we have successfully instantiated a class of Naive Bayes for model training and testing. So the next thing to do is to predict with the test set, which is the 20% of our data set. So now with this Naive Bayes model now, we can see that from its prediction, we have purchased and not purchased. So that means that the classification value for this model is a little better than the formal model, which is the logistic regression. So let us build a confusion model for the Naive Bayes. Now from the confusion matrix that we have seen, normally we read confusion matrix as a diagonal value. The diagonal gives the good result. So from here now, we can see that out of 54 samples for not purchased, 49 were correctly classified as not purchased, and out of 26 for purchase, only 19 were correctly classified as non-purchased. So now we move on to check for the accuracy value. What is the accuracy value? We have 0.85, or we could say is 85%, which is a better value than our logistic regression model for the same data set. Then we now also go ahead to use our F1 score, which gives us 0.76, which is still better than our logistic regression model that gave us 0.0. So we can still go ahead and also learn on more models so that we can compare many models together. From the beginning, we said that we have 5 models that we are going to compare together. So this is our third model named random forest. Random forest is an example, and you import the example of random forest as random forest classifier. Then you also try to instantiate a class for the random forest classifier and train and fit your trained data set into the model. So we have successfully created an instance of random forest classifier. So now we try to predict with a test data set on the random forest algorithm, and the result it gave is still better than the logistic regression model, as we have purchase and non-purchase in our prediction. So let us build a confusion matrix for our data set. So building the confusion matrix for our data set, if you read diagonally, we see that for confusion matrix for random forest, 45 out of 54 samples for not purchased were rightly classified as not purchased, while out of 26, only 23 were correctly classified as purchased. So we now try to measure the accuracy of our classifier, and we see our result to be 0.85 or 85% accuracy value. Then we also try to run our F1 score and let us see what value we have. We see that for our F1 score, we have 0.793, which is a value that is higher and better than logistic regression model. So we also try for extreme gradient boosting model for our trained data. But before you can use this XGBoost model, you first of all have to install the model. On your command prompt, you type pipe.install.xgboost XGBoost and click enter. Then it will successfully install the XGBoost for you. Now, after installing the XGBoost, then you can now use after installation. So as our tradition from time past, you first of all import the classifier, the XGBoost as XGBC classifier. Then you also instantiate a class for it and fit the train data to the model. So the next thing is to now learn the text data on the model. So you have the SGB prediction, and we could see from our prediction that you have values for purchase and not purchase. So this model is still better than our logistic regression model. So we try to build a confusion matrix also. So from our confusion matrix, we could see that 46 of non-purchase were rightly classified and 18 out of 26 were rightly classified as purchased. So now we try to run our accuracy value for our XGBoost model, and we discover that we have 0.8 or 80%. And if we run our F1 score, we have 0.692 for our F1 score, which is still better than the logistic regression model. So we still continue to build other models. This is a support vector machine, and before we can use that, we first of all have to import the support vector machine as SVC. Then we also instantiate a class SVC with this code, and we try to fit our data into the model, our trained data into the model. So we have successfully built a class for support vector machine. So the next thing that we do, we had already fit our trained data into the model. So the next thing to do is to predict the next, to predict the test data set with our model, which we have done. And our model also was able to clearly build a distinction between purchase and not purchase. So we now build our confusion matrix. So from the confusion matrix now, we could see that was able to correctly classify non-purchase as non-purchase with 51 clients, but for purchase, only 13 out of 26 were correctly classified as purchased. So let us run our accuracy value. So we have 0.8, which is 80%, and also our F1 score, which is 0.62. So now building our model summary now, we could see that the accuracy for all of the values, we have random forest having 83.75 and 77.97 for our F1 score. So, and we also have support vector machine as 80% for accuracy and 63.65%. So from here now, we choose the best accuracy value for your work, and we choose the best accuracy value. Now, we decided to choose random forest because the accuracy value and the F1 score were very consistent. So now the class activity for us now is to try these remaining 3 classifiers for the medical insurance Ethiopia dataset. So for class activity 2, now we have a dataset for employee retention in a company. You can also get the dataset from Kaggle here. This is the link, it is active. So the dataset is from the human resources department of one company in Somalia, and they want to determine what is making their staff to leave or not. So when you access the dataset, you attempt to answer some of these questions. Thank you for staying with me. See you in the machine learning for regression class.